Hi, welcome back for Section 5 of the Fire Dynamics course. The learning outcome for this section is to compare and contrast the underlying conditions that the three types of dynamic fire events have. Our learning objectives include defining a backdraft, defining a smoke explosion, and defining a flashover. Also indicating the conditions that lead to backdraft, indicating the conditions that lead to smoke explosion, and indicating the conditions that lead to flashover. First event we'll look at is backdraft. When a compartment fire is ventilation limited, large volumes of flammable smoke accumulate along with heat within the compartment. This pushes the flammable gases within the smoke above their ignition temperatures. Oxygen is the missing piece of the fire tetrahedron. When oxygen is introduced through ventilation, a deflagration, which is an explosive rapid combustion, can occur, which is called backdraft. A backdraft does not typically occur immediately after an opening is made on a structure. Depending on the size of the compartment and the size of the opening, it can take several minutes for the ratio of fuel to oxygen needed for backdraft to occur. For example, the smaller the size of the compartment, the quicker it may occur, or if we have a larger opening, it may occur more quickly. Conditions indicating backdraft include ventilation limited fires, which we've discussed, which is heavy fire in the structure with limited openings, which means limited oxygen available to the fire, pulsing smoke around small openings, high velocity smoke, little or no visible flame, heavy volume of smoke, dense smoke, and fast moving smoke, and high interior temperatures. So we're going to watch a video now that demonstrates a backdraft event that happened at a real fire, and we'll talk about the conditions.
Can they all get out? That's what I'm worried about.
So in that event, we can see above, especially the front door, that we did have a high volume of smoke, had some velocity, certainly had density, certainly had some turbulence. Right? So it was indicative of backdraft, as well as the fact that it was ventilation limited, a lot of smoke in the building, and no visible flame. The unfortunate part for firefighters and civilians is very difficult to predict when these backdrafts will occur, like other hostile fire events. Next event we'll look at is smoke explosion. A smoke explosion, also called a fire gas ignition, is a lesser known hostile fire event. It's defined as the ignition of accumulated smoke or fire gases that are within the flammable range upon the introduction of an ignition source. So accumulated smoke may occur in compartments within the structure or within void spaces. For example, within walls, right, or within attic spaces, anywhere where there can be an accumulation of smoke but no open flame. Conditions that indicate smoke explosion: a little more straightforward. It's any accumulation of smoke in compartments or void spaces. The rule of thumb for us to remember is that smoke is fuel. Smoke explosions may occur some distance from the seat of the fire. And the third hostile fire event that we will look at is flashover. Flashover is defined as a rapid transition from the growth stage of a fire to the fully developed stage. The flammable conditions of the room, down to the floor, will ultimately ignite in flashover. Conditions indicating flashover include increasing volume of smoke, darkening smoke, increasing turbulence in the smoke, rollover in the hot gas layer near the ceiling, and we'll explain the term rollover in the next slide, increasing temperatures within the compartment, and a lowering neutral plane. By a lowering neutral plane, we mean that the smoke is coming down from the ceiling and getting closer to the floor. So rollover can be a preceding indicator of flashover, and it is defined as the ignition of unburnt fire gases at the ceiling level. The visible flame that is seen at the ceiling level is a thin layer where the fire gases are within their flammable range, right here, and have hit their ignition temperatures. Above this place where the rollover is occurring, this is fuel rich but not enough oxygen to burn, and down here we have lots of oxygen but no fuel. So it's a thin layer where we see that rollover rate where the fuel meets the oxygen. Here's another video demonstrating a flashover. So we have the ignition of the fire in the incipient stage, and we'll shortly start to see the development of a plume of smoke and heat. Goes up, hits the ceiling, and then we have the formation of the ceiling jet. One other thing we're going to point out to you here along the couch as the fire grows and goes through the growth stage is we're going to start to see pyrolysis, which is that off-gassing of the solid fuels as they convert into a gas. And then we'll also see it along the floor, but we'll first see it here on the sofa. Notice how within an enclosed space how fast this room becomes untenable. So there's the pyrolysis that I mentioned, the off-gassing of the solids. Very quickly the couches and chair get consumed in fire, and now we're proceeding rapidly to flashover. See the intake of fresh air from outside the room. It's also drawing some smoke back into the room. And we go to a flashover in under 3 minutes. These conditions would be untenable for civilians and firefighters, even in full PPE and self-contained breathing apparatus, unless that firefighter had a charged hose line with them to put water in the fire. In conclusion, backdraft, smoke explosion, and flashover are all hostile fire events that are dangerous to civilians and firefighters alike. These events can be difficult to predict, but there are identifiable conditions that serve as a warning. In the case of backdraft and smoke explosion, there are missing pieces of the fire tetrahedron that, when they are put into place, can trigger the event. And as we saw in the all three conditions, it really goes back to the smoke characteristics: volume, velocity, density, color, and flow. And they are good indicators of all three type of events. In closing, for the course, although the science of fire does not change, our understanding of it deepens over time. There's been a lot of work done by organizations such as Underwriter Laboratories, UL, and NIST in the United States, who have deepened our understanding of fire dynamics over the last 10 years. Also, the tactics of structural firefighting should use our knowledge of fire dynamics as its foundation. As we know, the actions that we take as firefighters in the fire ground can have an impact on the dynamics of the fire. So if you have any additional questions, you can certainly post them to the discussion board, or feel free to send me an email. And thank you for taking the course today.